Let's take a few minutes and talk about how we measure the strength of tornadoes. Let's look first at some statistics that have happened with tornadoes over the past handful of decades. We'll start off by looking at the 1950 decade, 1950 to 1959. They had roughly 480 tornadoes per year. That means that for these 10 years, there was a total of 4,800 tornadoes. So per year, since there were 10 years, that means about 480 tornadoes per year. Likewise, about 1,480 deaths in that decade, so about 148 deaths per year on average. And you can see that that information is up here for every decade since then. This last decade is not yet complete in this table here. We're still compiling that data since that decade has just finished, this being 2020. I want you to notice a couple of things. First of all, the number of tornadoes per year has been steadily increasing. And from 1950s to now, we have over 3 times as many tornadoes per year as we did in the 1950s. Why? Oh, go shout it from the rooftops. We've got global warming. The world's coming to an end. No, it's not global warming. Take a note here. More tornadoes are being reported as populations increase. More people are around to actually see these tornadoes, and spotting technology improves. We're able to better detect these tornadoes than we were in the 1950s. As a result, we've been able to see a whole lot more, and it's good because now that we see more, we can study more, we can give more advanced notice, and we can save more people's lives. As you can see here, the number of deaths per year, for the most part, except for here in the 1970s, the number of deaths per year has pretty much decreased the whole time, except for the 2010s. What happened here? How did we always decrease, then all of a sudden we doubled any other year? Well, that has to do with the fact that each of these numbers is an average over 10 years, where this number is only an average of 3 years. 2011 was a very bad year. We had tornadoes in Moore, Oklahoma, Joplin, Missouri, and lots in Illinois. It was a bad, bad year in 2011. But since that's only 1 out of 3 years, that average is going to be really high because of 2011. Now, notice what happens when we add more years. This figure you're looking at right now is the figure from the 7th edition of your textbook. I'm going to show you the figure from the 8th edition of the textbook, which includes more. Now we're going 2010 to 2015. The number was 226. There it is, 226. And now it's 136. It's dropped. Why? Because that 1 year, 2011, is now an average of 6 years from 2010 to 2015. And since it's an average, just 1 out of 6 years, the total number of tornadoes, total number of tornadoes per year decreases. We've got a note here. 2011 was a deadly year, 553 deaths in 1 year alone. If you cut 2011 out, the average for all the other years averages to about 53 deaths per year. So really it is quite consistent with the rest of the other decades. It's just 2011 that was an especially bad year. Okay, we measure the strength of a tornado using the Fujita scale. Now, we don't have weather sensors inside of a tornado. That would require an insane amount of luck. First of all, that the tornado would strike where you have a weather station, and second of all, that the station would survive the tornado. It just wouldn't work. Maybe you've seen the movie Twister, where they put sensors into a tornado. Yeah, that's a possibility. that's science fiction. That's not going to happen. That's a huge strain on economic resources. It's um, dangerous, and it would require an insane amount of luck. Anyway, so the twister idea of measuring a tornado is out of the question. So what we do is we base the tornado strength on the damage created by a storm on a house. Okay, where F0 would depict the weakest of tornadoes and F5 would depict the strongest of tornadoes. And what we have found is, yes, the amount of damage done on a house does very well indicate the amount of wind that a tornado had. It really is a very good indicator, except for one problem. Tornadoes don't always hit houses. Sometimes they're out in the middle of a field, sometimes they hit industry areas. Just having a house as a reference makes it hard to measure the strength of all tornadoes. So we have now what's called the enhanced Fujita scale, which includes damage from more than just homes. You have an enhanced Fujita scale, or EF scale, going from 65 miles an hour being the weakest EF0 tornado, 111 miles an hour becoming an EF2, a strong tornado, 166 miles an hour would be an EF4, a very violent tornado. By the way, here you're getting into Category 5 strength hurricane winds. That's what we're talking about there. Anything over 200 miles an hour would be an EF5. And if you want to know more about the Enhanced Fujita Scale, this is the National Weather Service Storm Prediction Center, SPC. And they have an article on the Enhanced Fujita Scale. It's a very good description of it. Okay, so I gave you the numbers. What does that actually mean? Well, with an EF0, you're going to have some damage. Things are going to be blown over. You're going to have some shingles lost, perhaps some siding damage, maybe a window or two out, something like that. So damage, but not irreparable. EF1, you're going to have some much more serious damage. Trees are being uprooted. Sheds are starting to collapse. All the shingles are gone. Some of the paneling underneath the shingles are starting to go. Windows are going to be out. It's going to be pretty bad. But still not irreparable. EF2, you start to get complete devastation to light structure buildings like sheds or trailer houses, trailer homes. You're going to start getting structural damage in homes and businesses. Cars can start being flipped over, and you're going to start getting some more extensive damage in businesses as well. EF3, you're getting some pretty serious structural damage. Walls are starting to be torn apart. EF4, pretty much all the walls are knocked down. EF5, not only are they knocked down, but they are carried downstream along with the tornado much further. So that's kind of a visual of what you might expect with a home based on the Enhanced Fujita scale. So let's say that you are at home, and then all of a sudden you get an alert on your phone, and it says, tornado in the area, seek shelter now. Where do you go? Well, the best place to go is a basement. Why? A tornado's winds, this is a good one here. You're going to have winds that'll be coming along the surface and spiraling along the surface around this low pressure system and then up. Anything that's below the ground will not be caught in that wind pattern. So if you can find a place that's below the ground level, that would be best. So a basement would definitely be best. We live in Florida. We don't have basements. So what now? You go to a small interior room on the ground floor. The higher up you go, the more at risk you are. So you want to stay on the bottom floor. You want to be on a small interior room. It's been suggested use a bathroom. Why? Well, bathrooms are great because you have lots of pipes in the walls. Those pipes help to reinforce the walls and help to add some stability to the room, decreases the chance of the room collapsing. Now, you also want to be on the interior of your house. You don't want to be in a room that's on the edge of the house. Why? Because as a tornado comes by a house, remember, its pressure is really low. So the pressure inside the house is quite high. And as soon as a window breaks, well, now you're going to have air moving from the high pressure inside the house to the low pressure outside the house. And yes, things can get sucked out a window that way, just from getting caught in that pressure gradient from the house to the outside. Where do we see the most number of tornadoes? Well, Tornado Alley in the United States is the #1 hotspot in the world. The reason for this is we have the perfect setup with warm, moist air coming from the Gulf of Mexico and cold, dry air coming from the Rocky Mountains. Perfect setup for tornado formation. We're going to see the tornadoes happen most frequently in the spring. That's when you're going to start moving that warm, moist air from the south, and you still have the cold, dry air coming from the mountains. You're going to have the lowest frequency in the winter because the warm, moist air is kept south in the Gulf. Now, there is another place in the world where they do have a fair number of tornadoes, and that would be by the Alps, because you have the Mediterranean Sea and the Alps, and so you get the right conditions for tornado formation, but not quite as much as here in the United States. So here's a map of the United States. The colors indicate the number of tornadoes annually as an area of 10,000 square miles. So whenever you see the blues, you have an average of 1 to 3 tornadoes per year. Yellows would have an average of 7 to 10 tornadoes a year. Reds, you have an average of more than 15 tornadoes a year. And the numbers indicate the average number of tornadoes per year by state. Notice who has the highest number in the United States. You would think your eye is automatically drawn out here to the Great Plains. Oh, look, Kansas. No. Florida. Florida has more tornadoes than any other state per year. Why? Well, first of all, our area is smaller than that of Kansas, and so that factors in. So Kansas has a much larger area, so since they have a larger area, they have a lower number of tornadoes. That's not the big thing. The big thing is hurricanes. We get hurricane-embedded tornadoes here in Florida, and that increases the number. But if you look strictly as a function of square area of land, Kansas and Colorado, Oklahoma, and Nebraska, this area here, Tornado Alley, definitely has the highest frequency. When do we see the tornadoes the most? Well, this is the average number of tornadoes per month in the U.S. You can see that in May, that number is definitely the highest. Now, we do sometimes see a secondary season in November. In November, we do see a fair number of tornadoes occur there. But definitely April, May, June is the peak season for tornadoes.